Python has two types of loop, for loops and while loops. We've already briefly encountered for loops back when we introduced significant whitespace, and we'll return to them soon. But right now, we'll cover while loops. While loops in Python are introduced by the while keyword, which is followed by a Boolean expression. As with the condition for if statements, the expression is implicitly converted to a Boolean value, as if it had been passed to the bool constructor. The while statement is terminated by a colon because it introduces a new block. Let's write a while loop at the REPL which counts down from 5 to 1. We'll initialize a counter variable called c to 5 and keep looping until we reach 0. Another new language feature here is the use of the augmented assignment operator to subtract 1 from the value of the counter on each iteration. Similar augmented assignment operators exist for the other basic math operators, such as plus and multiply. Because the condition, or predicate, will be implicitly converted to bool, just as if a call to the bool constructor were present, we could replace the above code with the following version. This works because the conversion of the integer value of c to bool results in true until we get to 0, which converts to false. That said, to use this short form in this case might be described as unpythonic, because referring back to the Zen of Python, explicit is better than implicit, and we place a higher value on the readability of the first form over the concision of the second form. While loops are often used in Python where an infinite loop is required. We achieve this simply by passing true as the predicate expression to the while construct. Now you're probably wondering how we get out of this loop and regain control of our REPL. We press Ctrl+C, which Python intercepts to raise a special exception which terminates the loop. We'll be talking much more about what exceptions are and how to use them later in the course. Many programming languages support a loop construct which places the predicate test at the end of the loop rather than at the beginning. For example, C, C++, C#, and Java support the do-while construct. Other languages have repeat until loops instead or as well. This is not the case in Python, where the idiom is to use while true together with an early exit facilitated by the break statement. The break statement jumps out of the loop, and only the innermost loop if several loops have been nested, continuing execution immediately after the loop body. Let's look at an example of break, introducing a few other Python features along the way. We start with while true for an infinite loop. On the first statement of the while block, we use the built-in input function to request a string from the user. We assign that string to a variable called response. We now use an if statement to test whether the value provided is divisible by 7. We convert the response string to an integer using the int constructor, and then use the modulus operator with the % symbol to divide by 7 and give us the remainder. If the remainder is equal to 0, the response was divisible by 7, and we enter the body of the if block. Within the if block, now 2 levels of indentation deep, we start with 8 spaces and use the break keyword. Break terminates the innermost loop, in this case the while loop, and causes execution to jump to the first statement after the loop, or in our case, the end of the program. Enter a blank line at the 3 dots prompt to close both if block and the while block. Our loop will start executing and will pause at the call to the input function, waiting for us to enter a number. Let's try a few. 12, 67, 34, and 28. As soon as we enter a number divisible by 7, the predicate becomes true, we enter the if block, and then literally break out of the loop to the end of the program, returning us to the REPL prompt.